This is an example of a box where we're building a box, and we are using a 16-inch by 30-inch piece of cardboard and cutting out squares in the corners and folding it up to make a box. What size should our square be to obtain a box with the largest possible volume? Okay, so what you want to look at is you want to look at volume. Okay, volume is length times width times height. Length times width times height. So what you want to look at when you are looking at that is you want to look at, okay, what's the length? The length, if you cut out x from both sides, is going to be 30 minus 2x. The width, since I have 16 inches but I'm cutting out x from both sides, is 16 minus 2x, and our height is equal to x. Okay, now multiplying out, and I'm not going to bore you guys in the video with multiplying all of that out, we get okay, from here we find our derivative. Okay, so we get 480 minus 184x plus 12x squared. Now what I didn't do is I didn't look at my domain restrictions. Well, x is going to be between 0 and now think about it. If one of these quantities was 0, that would make our box not exist. If x was anything more than 8 inches, I can't cut in 9 inches one side and then equally 9 inches on the other side. So x has to range between 0 and 8 inches. Okay, now we set our derivative equal to 0, and I notice that I can factor out a 4. Okay, now factoring that even more, okay, so our possibilities are x equals 12 and x equals 10/3. Now the reason that I remembered to find my domain is 12 is not in our domain. I can't cut 12 inches from both sides because that would make this quantity not exist. Okay, so now we need to justify that what our answer is by using the first or second derivative test. Now I'm going to use the first derivative test. So I'm going to look at the sign of our first derivative, which is volume, to the left in between 0 and 10/3, and from 10/3 to 8. Now remember, you're looking at what the sign is in your derivative here. So between 0 and 10/3, I'm going to plug in 1, just makes my life easier. If I plug in 1, we get a negative times by another negative, so we get a positive. So we know that our graph is increasing. Then when I plug in something between 10/3 and 8, we're negative, so then we start decreasing. So I go from increasing to decreasing. We have a max at x equals 10/3 because v prime of x changed from positive to negative. Okay, so I have a max at that value. What size square should be cut? So make sure you're answering the question. We have a 10/3 inch by 10/3 inch square that we're going to cut.